Hello! Today in class we're going to solve equations with two variables. And today in the lesson we're going to study with you the algorithm for solving these equations. I would like to draw your attention to a very important algorithm that is used to solve any equations. Let's write down the simple equation that we have been studying. And we said in the previous lesson that the solution to this equation is a set of pairs of numbers. For example, pairs like 2, 6 or 6, 2 or 1, 7 and so on. You can write down many such pairs of numbers. But if the equation becomes more complicated, what should we do in this case? The thing is, in math, a very important skill is the ability to express one variable through another. What does this look like in math? What is the purpose of this? The thing is, in this equation, I can write the variable x on the left side, and I can put the variable y on the right side, and the result would be x equals 8 minus y. Why do we need such a notation? The point is that if instead of y I take a number, say 1.5 tenths, then I can use our new expression to write down what x equals. In this case, what should I do? If I say that y equals 1.5, then I can substitute that value in place of y. And then I can find the value of x. Let's write down that value. X then equals 8 minus, and in place of y, I'll substitute 1.5. And then I have x equals 8 minus 1.5. That's 6.5 tenths. So I found another pair that is the solution to our equation. Let's write down this pair. X equals 6.5 tenths. And y and so I can write down a pair of numbers that will be the solution to our two-variable equation. But in math, when expressing one variable through another, we can write down another way of finding these values. This is a way of calculating the pairs of numbers that will be the solution to our equation, can be written as a table. I'm going to build a table. In the first row, I'll write down the variable x, and in the second row, I'll write down the variable y. And then if I substitute 1.5 tenths for y, then I can calculate the value of x, and we've calculated the value of x. It's 6.5. If instead of y, I substitute a value of 3, then I can use our expression to find the value of x. To do that, I need to substitute 3 in place of y, and then x equals 8 minus 3, and 8 minus 3 is 5. I write in the line for x the value equal to 5. And I end up with another pair, which is the solution to our equation. Let's write this down. Instead of x, I write down 5 and y equals 3. So I can write down any number in place of y that satisfies, of course, the domain of definition. But in our case, there is no restriction on x and no restriction on the variable y. Let's calculate what x equals if y equals minus 9. What are we going to do? We go back to our expression and find x. In this case, x equals 8 minus y. Be careful, because instead of y, we substitute a value equal to minus 9. And then we have 8 minus minus 9. And then 8 minus minus 9 equals 17. And the value of x equals 17. So we have found another pair that is a solution to our equation. Let's write down this pair. instead of x, we write 17, and instead of y, we write -9. But very importantly, when you write down the answer, make sure you write the x value in the first place and the y value in the second place. Using this same algorithm, we can express not only the x variable, but also the y variable from our same equation. If I write down y equals, in this case, v equals 8 minus x, and using the same algorithm, I can also identify pairs of numbers that are solutions to the equation. In the next lesson, we will solve some more equations with two variables, and for today, our lesson has come to an end. Goodbye, see you again.